Now let's move on to the second question, which is about the Armstrong number. Now this question says that write a program to input a 3-digit number, use a method int, that means it returns int, Armstrong, and it takes an integer to accept the number, and then the method returns 1 if the number is Armstrong, otherwise 0. Now to do this, you need to know what is an Armstrong number. We'll discuss that. First, we'll go with the same approach of writing a pseudocode. So I've written a pseudocode like this. We will write a function and it will be named Armstrong, and it will take an integer number. So far, because it's a pseudocode, we are not taking care of the syntax. We are trying to build a flow and logic. Okay. The logic, I think you know, in the interest of time, I'm combining both. Otherwise, you'll have to think what is an Armstrong number, which you can anyway learn from this. First, we will set original number n, which we will receive, and we'll set another variable sum. So we are kind of taking two variables, the original number and the sum. Original number is taken from this function's parameter, and it is assigned to original, and there is a sum. Initially it is 0, and while the number, which one number? This one. While this number is greater than 0, we are going to keep doing it. Now what are we going to do? We are going to do this 3 steps. Get the last digit of the number. How you are going to get that? You're going to divide it by 100. It's a 3-digit number. You divide it by 100, you get it, right? Add last digit cubed to the sum. So whatever number you get, for example, you get a, you need to do a cube plus sum. So you're going to add it to the cube to the sum, and then remove the last digit from the number. Just like you remove the last digit from here, you're going to remove it, right? It's a 3-digit number, so we can go ahead and divide it by 10 next time. First we did 100, now we'll do 10. Now if the sum equals original, what is the sum? We get the sum every time at this step, right? If that is equal to the original, so if sum is equal to original, then return 1, right? This is the logic and also the flow. Now think of the main program. You have to ask a user to give a number, so you will ask the user to print a number. So you will do a scanner to get ready to read a value, and then you'll print, right? And then you call the Armstrong function with this number as a function call, right? And then based on the return, if it returns 1, you print it is Armstrong number. Now what's your question? You have to print it is an Armstrong number if it is 153, right? And it returns 1 if it is an Armstrong. So you check if it is 1, you return, and you get an Armstrong. Now let's get into the logic. Just like you had a function here, we are going to write a function here too, right? We are going to write a function that is we'll write Armstrong number class, which will have a method called Armstrong, right? So we make a class here, which is the total class of the program, including the main, and this has 2 methods, Armstrong and main. What you do here is, in Armstrong we are receiving an int, we are going to return, okay, returning an int. Earlier we had a return of double in the previous case. Now you save it in some variable orig, and you start with sum as 0. These are, why do you save it in orig? Because n may change every time you operate on it, n will change. So we are keeping the orig so that we can compare later on sum is equal to orig. In the pseudocode we compare, sorry, here's the pseudocode. In the pseudocode we compare if sum equals original. So that's why we are keeping orig here, and we are working on n. So while n is greater than 0, int digit is equal to n%10. So you just take the modulus here. So get the last digit, either divide by 110, whatever you're trying to think of. How do you get the last digit? If you do modulus n10, you get the last digit, right? And then you add that raised to the 3rd power. You ignore this b:3, okay? You ignore that. Math.pow. You're going to use java.util scanner to read, which we'll read here, but math is inbuilt, so you can use math.power. The digit, what is the digit that you get here? Raise it to the power of 3, add it to the sum, okay? And then change n, because n has to be changed in the next time it goes and does that while loop, okay? So you divide n by 10. So if it is 153, right, you took a modulus and got 3, and here you take divide by 10, so you'll get 15. Now 15 goes here, 15 turns, take the last digit, you get 5, you do 5 cube, it goes on till that. Now finally you do a sum is equal to origin. If it is true, then return 1. This is a short form, or you can write a longer if else, right? Now your Armstrong method is ready. That is what your question was. It asked you to write an Armstrong. We wrote it. Now we have to execute and show it. To do that, we have main. So you have public static void main string args, you know this. Use a scanner because you have imported it to read that. You read it and put it in a variable. So you ask the user now, go ahead and enter a number. And when he enters a number, you use the scanner object to get the integer. You read that integer, that becomes your number with which you call the Armstrong, right? And here the flow will move on to this method and it will either return 1 or 0. You can write a simple case, okay? If sum is equal to origin, then return 1, else return 0. You could have written that as well, right? Now, since you have taken it from the user and you got a result, what are you going to say? That if result is equal to 1, you can just print this part. You don't have to do all this, okay? This is an explanation. You could have skipped it. If result is equal to 1, you just want to do this. So I'm going to skip this part, okay, to make it simple, and I'm going to save it. Now I'll go to my terminal and I'll try to compile it. Okay. And I have my Armstrong, so I'll call it Java compiler. I'll run this. I hope I don't have an error, right? I don't have. Then I run this. So I'm going to enter a 3-digit number. It's an Armstrong. Now if I had the earlier code that I had, which is not a part of what they want you to do, then if I go ahead and compile, okay, let me compile it, and now I'm going to run it, and I run 153. Yeah, I didn't save it, I didn't change. Okay, I should have done this. Compile, run, I write 153. So it is trying to give an explanation. That's not what you should do, okay? You don't have to explain all this, right? So you could have simply skipped this part and this is enough, right? That's how you write. So always take the help of a pseudocode. We'll meet in the next question.